Alright, so let's continue going over our practice with these last three examples. One of the things you should start to notice here is some of these examples are going to look more and more complicated, and in reality they are, but for a lot of these nomenclature questions, regardless of how complicated we make the example, it really just adds more steps to it. And as long as we approach these in sort of a step-by-step, fashion, find the parent chain, find the find the correct numbering, name the substituents, combine them, alphabetize them, we end up with a lot of the same steps. So in this one, our longest chain goes straight down the middle here. And if we started on the right side, our first substituent's on the second carbon. If we started on the left side, we don't get our first substituent until the third carbon. So this one is going to get numbered from right to left. At this point, I want to list my substituents. That way I have them organized. So I have methyls. Oh, that was weird. We have methyls. Methyl at 2. At 3 is another methyl. On the fourth carbon, we have an ethyl. On the fifth carbon, I have an isopropyl group. On the sixth carbon, I have a 4-carbon chain, which would be known as a butyl group. And on carbons 7 and 8, we also have methyls. So here, we just need to name these substituents in alphabetical order. So butyl, starting with B, will come first, followed by 4-ethyl. Then recall for isopropyl that the prefix iso is not a numerical prefix. So isopropyl gets alphabetized under I. Finally, we have all of our methyl groups, 2, 3, 7, and 8. There's 4 methyl groups, so we use the prefix tetra. And then our parent name, decane. All right, our next example is again going to be a pretty straightforward one to find our parent chain. We should see that that parent chain again goes straight down the middle. Where this one may get a little bit more complicated is determining how to number it. So let's do both possibilities. So left to right, we're going to go in blue. And you can see that our substituents are at 2, 3, 4, 6, 7, 8, and 9. Going right to left, we'll use orange. And we get substituents at 2, 3, 4, 5, 7, 8, and 9. So our first substituent, each direction, same number. Second one, same number. Third one, same number. When we get to the fourth substituent, though, starting on the right side with the orange numbers, we have a lower number for that fourth substituent than we do coming the other direction. So that means the orange numbers are what we need to use here. So what are our substituents? Well, on the fourth carbon, we have a sec-butyl group. Remember that sec-butyl, sec is numerical, it gets alphabetized under I. Now, the reason I didn't go through the list of substituents like I did in the other case is because the other thing we have is our only methyl groups. And so now we just need to list and count up all the methyl groups. 2, 3, 5, 7, 8, 9, hexamethyl, and then the parent is decane from 10 carbons. All right, one more example on this practice sheet. Again, we have our parent chain straight down the center. And if we number it in each direction, starting from the right, we have our first substituent on the second carbon, whereas starting on the left, our first substituent is on the third carbon. So we know we need to go from right to left here. So in this case, I'm going to list them because we have a lot of different substituents here. We have 2 fluoro. On carbon 4, we have an ethyl. 5 gives us an isobutyl. 6 is a propyl. And 7 is chloro. So from here, we just need to put them in alphabetical order. So 7 chloro, 4 ethyl, 2 fluoro, 5 isobutyl, 6 propyl, nonane. And so as we end this section on nomenclature, I want to stress again, it's really important that you get a good grasp on this nomenclature early on, because as we go further in this course, what we're going to find is that we really need the alkane nomenclature to learn the nomenclature of every other functional group.